Okay, so we are moving to exponential equations and how to solve for these exponential equations. Okay, so if I have something to the power of a variable, right, and I want to know what that variable is, I need to be able to solve for that. Okay, so an exponential equation, this is just a definition of exponential. So an exponential equation that contains a variable in the exponent. Okay, so that defines an exponential. So remember that with an exponential, you have the base and you have the exponent. Okay, so for example, if I have 2 to the power of x, we call it exponential because your exponent is a variable. Okay? If you have, let's say, 1.037 to the power of x, this is another example of an exponential. Okay? Because your base is the number, your exponent is the variable. Are we okay with that? With the definition of what exponential equations look like? Some exponential equations can be solved without technology by writing both sides of the equation as powers of the same base. So here's an example. So if I have 2 to the power of x equals 2 to the power of 3. What is that telling you? What does that tell you? If I'm telling you that 2 to the power of x equals 2 to the power of 3, what does that tell you? Do you have the same base for both sides?
No.
You don't have the same base? Do you have the same base or no?
Oh, yeah.
Okay, we have the same base, right? So since we have the same base and there is an equal side, so right away, I can say that my exponents are equal. Therefore, x is equal to 3, right? Why can I do that? Because both bases are the same. Okay? So as long as I have the same base on both sides, then my exponents are equal to each other. So here's the rule. The rule says, if a to the power of m is equal to a to the power of n, that means m is equal to n. Right? Because I have the same base, that right away makes my exponent equal to each other. As long as a is greater than 0 and cannot equal to 1. Why a cannot equal to 1? How about if I have 1 to the power of m equals to 1 to the power of n? Does that have to be that m is equal to n? What's 1 to the power of 10? 1. What's 1 to the power of 15? 1. That's going to still give me 1. Both of them are going to give me 1. But are my exponents the same? Are my exponents the same? They're not. One is 10, the other one is 15. Yet my answer is still 1 for both of them, right? So in this case, my exponents are not the same. So that's only the case for 1. If the base is 1, it doesn't work. Okay? Because that's if a cannot equal to 1. That's why we have this. A cannot equal to 1. Okay? That a has has to be greater than 0. Now, let's look at this example. So, if I have 4 to the power of x equals to 4 of 3, then I can say what? What's x equal to? X equals to 3. Right? Since 4 to the power of x and 4 to the power of 3 are both powers of 4, so the base is 4, the exponents must be equal. Okay? So when I'm solving for this, I can say that x is equal to 3. That would be my solution. Okay? So let's look at the examples. Now sometimes if it's not already the same base, then you have to make it the same base. And we're going to talk about that. So I have 5 to the power of x equals 5 to the power of 6. What does that mean? If I want to solve for x is equal to what? 6. Done. Why? Because I have the same base. Both bases are 5, right? So then I can make my exponents equal. How about B? Do I have the same base? No. What would be my base if I want to make them the same base? What would be the base that I'm looking for? What's the base for the left side? 2. So 2 to the power of what gives you 32? You can use your calculator and try it. 2 to the power of 3, 2 to the power of 4, until you get something that gives you 32. Right? So now I made them the same base, correct? So now what can you tell me that x is equal to? X is equal to 5, and that's my answer. Make sense? All right. So 2 to the power of x equals to a half. What would be my base that I want? They don't have the same base, do we? We don't have the same base, right? So I wanna, the base here is 2, right? How can I make a half as a base of 2? What do we know about fractions? What makes it into a fraction? So look back here. Look here. Can you see this? What makes it into a fraction? Because of what? Negative exponent, right? So if I want to flip this, your exponent here is 1, right? If you want to flip this, it's going to be 2 to the power of negative 1, right? So that's the same thing as writing 2 to the power of negative 1, right? Because negative exponent makes your base flip with a positive exponent, right? Yes, x can be negative 1. The only thing that can't be negative is your base. Your base can't be negative, okay? Your exponent can be negative, okay? The base has to be greater than 0, okay? But your exponent, yes it can, it's x equals negative 1. Yes. So what do you think the next one is? What gives you 4? Okay, think about your base. What should your base be? 2. 2 to the power of what gives you 4? 2 to the power of 2. So that's the same thing as writing this, no? Right, 2 to the power of 2 gives you 4. So I change the 4 into 2 to the power of 2. Yeah? Now, I want to make it as a base of 2, so I have to flip. What happens when I flip? The exponent becomes a negative. So that's 2 to the power of negative 2, yeah? Okay, so what would be x is equal to? The exponent is equal to negative 2. Next question. 7 to the power of 3x minus 4 equals 49. What would be my base? 7. 7 to the power of what gives you 49?
So why is it 3x minus 4?
Because that's your exponent. We'll talk about that in a second. 7 to the power of 2. Okay? So, I have the same base now. Yes? Since I have the same base, that means my exponents are equal to each other. So, my exponents are equal to each other, so I'm dropping the base, and I'm keeping my exponent, and they're equal to each other. Right? So, because the bases are the same, I can drop the base, and then make my exponent equal. So 3x minus 4 equals to 2. How can I solve for x? What do I need to do? What's the first thing you want to do? Bring the negative 4 over first. Right? First you get rid of the addition or subtraction. Right? So I'm going to bring the negative 4 over, and it becomes a plus 4. So I have 3x equals 6. Then what do you do after that? How do you get rid of that 3? What's happening between 3 and x? Addition, subtraction, multiplication, division. What's happening between 3 and x? Multiplication. When I bring it over, what does it become? Division. So I'm dividing by 3. So that's x equals 2. Okay? So if I want to check my work, what I can do, eyes on me for a second. So I'm going to put 2 in for x. Okay? So that's going to be 3 times 2 minus 4. So 3 times 2, that's 6. Take away 4, that's 2. 7 to the power of 2 is 49. So my left side is equal to my right side, right? Because my right side is 49. Okay? So what I can do, plug in the value for x into the original formula and see if your left side is equal to your right side. Okay? I'm going to leave you to do the last one, and then I'll take it up. Okay?